here we are going to look at the introduction and ideas behind what's called the dot product. So the dot product is the product of two vectors, but it doesn't come out as being a vector, it comes out as being an actual value. Essentially what it is it's used in order to find what's called the angle between your vectors and to determine if your vectors are perpendicular to each other or not. So if we're given two vectors, then the dot product would be written as u, a big old dot, v, which is going to essentially be u1 v1 plus u2 v2. So that is your formula that you are using. Now there's some different properties that we have along with dot product. So for example, the dot product going one direction is the same going the other. So if we have u dot v, that's the same as v dot u. If you take a vector and use the dot product with 0, you're going to end up with 0. Now if you take one vector and you use the dot product with the addition of two other vectors, then essentially what you're doing is you're using the dot product of the first and the first term plus the dot product of your first vector, or the u plus the w. So what we're doing essentially is treating the first term almost like a scalar term. Now, when we're looking at the dot product, say we have a scalar on an actual scalar on the outside. So we have a times the dot product of u dot v, then that's going to be the same as a times v to the dot of u, which is the same as u to the dot product of a times v. Okay? And then last but not least, if you take the dot product of itself, that's the same as the square of the magnitude. So we've got some examples, which is the best way to try and explain your dot product and what it is that we're doing here. So we're going to go ahead and take a look at those examples. So first and foremost, we have that you need to find the indicated calculations given the following, and I'm giving you three different vectors. So we're giving you u, v, and w. This first one wants the dot product between u and v. So u is going to be 5, negative 2. So we're going to go ahead, 5, negative 2. And we are using the dot product between v, which is going to be negative 4, 7. So here we have to follow your definition, which says we're going to do u1 v1 plus u2 v2. Okay, so let's look at what we have. This is going to end up being u1, so 5 times negative 4 plus negative 2 times 7. We're going to 5 times negative 4 is 20, negative 2 times 7 is negative 14. And so when you add those together, you get negative 34. So notice here the result that we get is an actual number instead of a vector. Okay, let's do one more. Let's look at w to the dot product of u. So here this is going to be negative 1, negative 3 to the dot product of 5, negative 2. So here we're going to end up with negative 1 times 5 plus negative 3 times negative 2. Negative 1 times 5 is negative 5. Negative 3, negative 2 is 6. Negative 5 plus 6 is going to give me an answer of 1. Now, last but not least, I need to find the magnitude of u using the dot product. So here I've got the linear combination negative 3, 4. So what this actually tells me is that U has the component -3, 4. So I need to find the magnitude. So first and foremost, I have a formula here that I can use, which says I have magnitude squared, which is your dot product idea. So this would tell me that the first thing I'm going to do is find my magnitude squared. Okay, so I do that by taking the dot product of itself. So this is going to be -3, 4, and I'm going to dot product it to -3, 4. So in this case, this is going to give me -3 times -3 is 9, plus 4 times 4 is 16, which says that the square of my magnitude is 25. So to find the actual magnitude, says I need to take what I just found and take the square root of it. So my magnitude is 5. So I hope those examples kind of help to clear up a little bit of the dot product. The main thing that you just simply have to remember here is what the actual rule is and the different properties that you can do with them. So if you have any questions, as always, please let me know. If you have any examples or additional problems you would like to see, let me know that too. Otherwise, I do hope that you enjoyed sitting through this super fast introduction to the dot product of vectors, and I look forward to being able to see you next time.